My name is Mateusz Jamiołkowski. There is a typo on leaflet you got, but that's no problem. I work as software engineer for a company called KNS Software. And I'm not purely front-end developer. I've done some back-end development in C#, some iOS development. Now I'm working for Java and JavaScript project, which is quite heavy single-page application for British government. And my relationship with JavaScript is quite weird because this language has everything that I hate, which is dynamic typing, which is weak typing, which is lack of good IDE support. But for some reason, I love it. So it's weird, but it is. Okay, let's go forward. Come on, Chrome. So some time ago, JavaScript used to be only an addition for applications. For example, when I was told to write some JavaScript application, use JavaScript on university, teacher asked me to just add some JavaScript. So I created a website with a clock, which is completely useless. So JavaScript used to be language for doing such things, but this is no longer true. I think this language has place among the other languages like C# and Java. But it happens that not everyone knows that, and I've been working with some software developers which were really, really good, but they didn't know JavaScript, and they used to treat it as some language for adding clocks to websites. So I will try to convince you that you can find lots of serious enterprise-like features in JavaScript world, so you don't have to treat it as only some addition. So when our application grows, we need to start thinking about testing, and you can do that in JavaScript. I'm not going to talk about merits of unit testing, merits of BDD, and how you can drive your design with tests, because I assume that you all know that. But if you don't, then just take a look at some frameworks that are available in JavaScript environment. There are a couple of them. I mostly use Jasmine and Mocha, which are kind of BDD flavor, so they encourage you to write your tests in a proper way. But if you prefer a classic approach, you come from JUnit or NUnit and you are not really fan of BDD, then you can use some other frameworks as well. So I'm not gonna be trying to show you how to write code. I'm just gonna give you some options, and so you can choose from. If you write tests, then you need some mocking frameworks. Well, in JavaScript you really don't, because there is no static typing. You don't have interfaces. You don't have to implement those interfaces to inject them in some classes. But it's useful to have option to easily and nicely check if some method was called in your mocks. So there are some mocking frameworks for that. One of quite interesting one is Synon.js, which allows you not only to mock methods, but also you can mock whole server backend. So you can write your tests as close to the server as possible. So, for example, you can have some REST API and say that if you do a call to person/ID, I want to return this mock data without even calling server, without doing replacement of some repositories or some more advanced things. So you can stay as close to the server as possible, which is quite nice. But for example, Jasmine, one of frameworks I mentioned here, is running strictly in browser. So developer writes some tests and then refresh browser to check if tests are working fine or not, which is fine, but it doesn't work if you want to combine unit testing with continuous integration server. So for that, you need some test runner. There are a couple of those. I use first one, which is called Karma. So Karma is basically Node.js application, which when run, spawns instance of browser and connects to it using socket.io. So then it will use browser as slave and execute all tests within this browser. So you can integrate from perspective of CI server, this is just some application, some executable, so we can work really, really nice in command line. But that's not most, but you don't have to rely on browsers that have graphical interface. You can use Phantom.js, which is headless browser, so you can run it everywhere. Which is even more cool, you can use WebDriver, which comes from Selenium. And if you have account on a service like Sauce Labs, you can connect to that and have your tests running on some Linux-based server. I mean, triggered from Linux-based server, but then run them on every browser, on every virtual machine that they support. So you can say, this Karma ran me those tests on Internet Explorer from version 6 to 10 or some different versions of Chrome, so we can easily check if something fails or not. And it can be quite easily done with Karma. Inversion of control. This is quite controversial topic in JavaScript world. I'm not going to explain what it is, because if you don't know, then you probably don't need it, but some people who are coming from Java and .NET world, they are obsessed about IOC and they really need some IOC container. And not that long ago, if you checked Stack Overflow, people said that it is stupid. You don't need it in JavaScript because you can alter everything you have. So why would you need IOC? Or there are a couple of arguments for that, but not gonna talk about them now. But this approach changed because of a library called AngularJS, which was created by guys from Google. And I see it that way that they really loved Spring framework, which heavily relies on having IOC container. So they added IOC there, and for me, it works fine, and I really like it. And I think other AngularJS developers like it as well. So with Angular, IOC pattern and IOC containers came into world of JavaScript. We have some other IOC containers. I even created one myself, which is not difficult in this language. It took me about one evening. So you can write it one yourself if you really need it. Build tool in JavaScript. That can seem to be weird because build tool in script language. What? Why would you need something like that? So answer is simple. In JavaScript, you need to often bundle your code, minify it, compile CoffeeScript. If you use some transcompiled languages, TypeScript if you are coming from .NET world, or compile you less into CSS. And it's good to have some tool that can do that for you. So tool that I use is called Grunt. Well, I think it's the most popular JavaScript build tool. It is application written in Node.js, and all modules and extensions are written in JavaScript, so you can easily add your own tasks. If you want some comparison to other technologies, Grunt is like MS Build, or like Maven from Java world, or like SBT. God protect me from SBT. But when we have Maven and SBT or something like that, why would we need to use Grunt? Because many of those technologies let us to do some tricks with JavaScript. From my experience, I can tell that it's usually best to rely on Grunt to do JavaScript build, and just treat Grunt as a slave from those more proper build systems. Because if you, it often happens, for example, it happened for us in Play project where we used SBT and Play, that Play didn't allow us to do some advanced tricks with configuration because it required just configuration for ourselves. So it generally works fine when you start, but then you stumble upon more and more problems. Other quite nice feature that you can have in JavaScript is dependency management. So if you are a Java developer, then you probably use something like Maven or Ivy to download your jars, not to keep them in your repository. It's not that big problem in JavaScript with size of dependencies, but it's useful to have some tool that would allow us to download proper versions of libraries and automatically update them if some new version comes out. For that, we can use one of package managers. I'm going to talk today about NPM, which is specific for Node. In front-end world, we have something called Jam.js and Bower.js. So Jam allows us to, well, they are quite similar, but Jam needs some pre-prepared packages, which then nicely integrate with required.js. And Bower just downloads GitHub repositories, which is generally good because, at least from my experience, because some Jam repositories are configured in the wrong way. For example, AngularJS repository, it lacked some shim configuration, so if you wanted to use it properly, then it failed. And in Bower, you just get files that you then configure yourself. Downside of Bower is that usually repositories are downloaded as whole, so you can not only get your distributable version, something that you would like to have, but also sources, tests, and so on. Modules. In JavaScript, I think this was mentioned on one of previous presentations, but in JavaScript you don't have really some module pattern or import or require statement we know from PHP or other languages. So if I want to say that file A requires file B and C to work, then I have no way to say that. But there are solutions for that, module loaders, and the one I use is required.js. So instead of saying that in typical application that is not using module loaders, you'd have to put A in front of B and C in your HTML file, which is fine if you've got 3 files, but if you've got hundreds of them, which happens in bigger application, this is complete disaster. So take a look at module loaders and required.js. If you have a big application, they can really help you. When our project grows, we need more people. So then we need to agree upon some common coding standard to follow. So a good tool to enforce those rules is, well, it's not a tool, it's a technique called static analysis. In C# world, for example, we have style cop that can assure that everyone writes comments in proper place and so on. We have similar tools in JavaScript. Mostly this is JS hint, which is some less restrictive version of JS lint. We can configure what we want to check and what we don't want to check. So you can use that to enforce your coding rules, make sure that everyone puts commas at the end of lines, make sure that everyone uses strict statement in his function, and it will assure that if someone breaks this rule, you can configure it to work with Grant, and if someone breaks one of those rules, then his commit will fail on build server. When we are doing unit testing, we need some tool to make sure that we are testing well. Code coverage tools can help us with that. For application that uses Karma Runner, using Karma coverage package is quite a good solution. It uses Istanbul underneath. It allows us to measure coverage of our tests. So, for example, this is some simple report from Karma coverage package, which is HTML, and shows which lines were tested and which were not. And I would like to warn you not to use code coverage or linting tools as some strict metrics that are bound to be used by and followed by everyone, because you can get what you are asking for. For example, I've heard a story that was told to me by a colleague of a colleague of a colleague from some company that decided that they will pay testers for finding bugs. So then testers created some plot with developers, and developers were introducing bugs to code. Testers were finding them, and testers then get paid, and they split even with devs, which, well, they were finding lots of bugs, that was working perfectly fine, but quality of project didn't went up. So you can get exactly the same if you try to run your project just by metrics like code coverage. You can easily get 100% code coverage with tests that are not checking anything. So better, really better way is to rely on code reviews and use code coverage tool as support for you writing tests in proper way than just some metrics that says that project is working fine. Okay, so we've got all those things, and now we'd like to connect them with continuous integration server. So if someone writes some code that will cause unit tests to fail or will violate static analysis rules that we agreed upon, then simply build will fail and he will get message and his photo will be posted on whiteboard by a whole week. To do that, we can use Grunt and use it to combine all those tools that we have, and it's quite easy to do. Here, I created some project for you. If you are interested in one of those tools I'm describing here, you can download it and integrate it with, for example, TeamCity, which I've done while preparing to this project. So it's really easy. You've got to run 3 commands. First of all, npm install to install Grunt dependencies, all those plugins that we use that help us build our project, for example, less compiler. So that's another advantage, that we always know that everyone is using the same version of less compiler. So when we upgrade, we don't have to send mail to everyone. Then you've got to download your front-end dependencies using Bower by doing Bower install. And this will download libraries that we don't keep checking into our Git or Mercurial or whatever repository we have. Then we just do grunt dist, which will start building our application. So it will do compilation, minification, bundling, and so on. And after that, we have front-end application done. So in case of larger project like one that we have, this is not done directly, but this is integrated into SBT tool that is meant to build our Java project, and it just hooks up, it's hooked up in correct place, and it does the job while doing SBT build. If you would like to take a look at some of those tools, then just download a repo I created for you. It's really small and easy to follow. Okay, so that would be all. Do you have any questions? Okay, thanks.
Hey, I just want to ask about, you said you wired up Grunt and with a Play framework project, yeah? Am I correct?
Yeah.
And how you doing that? How you verified that the Grunt build was successful in the SBT?
Because if Grunt fails, it will return non-zero exit code. So then SBT will pick it up and return non-zero exit code as well.
Okay, so you just verified the exit code, you don't analyze the output from the Grunt in SBT anyway?
No, you don't have to, because those tools will return proper exit code, where improper exit code is something like, so it's quite easy.
Okay, thanks.
One question here. You mentioned you use SBT?
Yep.
To build Java?
Yeah.
Not Scala?
Well, SBT, it used to be Scala build tool, but now it's simple build tool to reflect whole simplicity of this beautiful build tool. So we have Play project that uses Java, not Scala, and then because we use Play, we are forced to use SBT.
All right. No, it's SBT is rather not simple, but
yeah, it's rather not simple, but so the name is quite funny.
Thanks.
Hi, hello. I saw that you were talking about, I'm here. Hello?
Oh, okay.
No problem. You were talking about Karma, and that Karma can spawn browser and so on. How do you handle Internet Explorer? Because as far as I know, Karma cannot spawn remote browser, for example, on Windows machine somewhere else. How do you handle this?
How we handle this in our project, we use something called Source Labs. So this is...
Okay.
Okay. Enough. Okay.
Yeah, thanks.
So for people who don't know Source Labs, I probably didn't explain it very well. It's like a website which has tons of virtual machines with different operating systems and different browsers on it. So you can choose to have Windows XP with, I don't know which version of IE comes with XP, 7, 8, something like that. Okay, 8, yeah, thanks. So with version 8, and then use WebDriver, which comes from Selenium World, to run your unit tests on this Internet Explorer. So that's the solution here.
Any other questions?
Okay, thanks.